Welcome to my talk, and as always, it is exciting to be here, as I will be talking about what has been going on in OpenSIPS land in the last year. About me, I'm an OpenSIPS developer and maintainer of various bits and pieces of the code. For the better of 12 years now. I work for a consulting company called OpenSIPS Solutions, and there is also this SIP Hub company that we use to sell some products. For today, yeah, be sure to, if you're interested in that, be sure to check out the siphub.com website and learn more about us. By the way, I have stickers towards the end of the presentation if you're interested in that, putting them on your laptops. So for this presentation, there's going to be a lot of IMS because that is the main topic of the 3.5 release this year. A lot of work has gone in that direction, and there are some other additions as well. And yeah, let's dive right into it. First of all, who is producing all of these drafts? Who is behind this? Of course, it's the 3GPP, which is a big organization made up of standards committees from all parts of the world, from the US, from Japan, India, China, Korea, and last but not least, Europe. So this is just the organizational part. There are maybe tens of others, maybe hundreds of mobile network operators who are who give contributions from a more practical perspective, let's say. So they are also behind the IMS and the loads of documentation that goes along with it. And I thought it would be interesting. By the way, let me know what I'm doing wrong with the microphone. Anyway. And I thought it would be interesting to share with you like a quick couple tips on how you should navigate their documentation and so as how not to get lost in the swaths of documents. And not only that, but these documents get revised. So with each maybe couple of years, they put out new revisions. And of course, the old ones, they are still on the internet. So for example, there are specifications on the very first interfaces, let's say the SH interface, that are for 20 years now. So you get like, yeah, a lot of versions to them. So this is what you should not do from my point of view. Don't just Google them, because you will get some random version. That is the problem. You might be working on the wrong document that is a few years behind. Rather, if you don't know its number, you can look it up on the 3GPP. But if you know it already, you just need to know this, that when they put out the standard, the ETSI, the European Telecommunications, validates it and puts a 1 in front of it. So that's all they do there. So now you look up the 129. Let's say we want 29329. Now we know which one to look out for. And there is this, I highly recommend if you're dabbling into this stuff, to bookmark that URL. It's a very nice directory with all of the documents, and you can be sure you are looking at the most recent one. So that is like a quick tip. OK, so let's go into IMS and what it means when we talk about these buzzwords, right? 4G, VoLTE, 5G. So this is their proposition of how a VoLTE architecture should look like. It might look complex. It might look a little bit, overwhelming at first. But at the end of the day, there is a lot of purpose into this, and it creates a sense of order when it comes to interoperability, right? Because imagine if various network operators were not following the standards, right, how would they interoperate? Let's say you've got an MVNO who wants to kind of lease some wireless from an MNO, from an MNO's infrastructure, cell towers, antennas, right? How would they be talking? Let me connect my Open5GS to your antenna, right? And then the MNO goes, wait, first of all, we don't use the word open around here. What is an Open5GS again, right? So now they talk in MME and SGW, PGW, CCSF when it comes to IMS, and all of these abstractions which make sense when talking operator to operator. So with OpenSIPs and SIP, we are pretty much only looking around the IMS part of this architecture. Here is another way to look at it, a bit of a zoom in on the IMS core over there, where we can see two different colors, right? There are the yellow interactions, which are the SIP, which is the diameter protocol, and there is the teal interactions, which is the SIP we all know about. And concretely with OpenSIPs, we have the PCSCF, which is the proxy, the entry point to the IMS core, and the I and S CSCF. By the way, CSCF, call session control function, right? We are controlling calls. A lot of this is function-based, right? It is an architecture focused on microservices. So we want to answer the question, okay, what are we missing, right? What do we need until we have full 4G IMS CSCF support? And we took a look at various bits and pieces, also got feedback from the community, people who are trying to implement this. And we came along this spec, the 24229, which is a PDF of 1,200 pages. It is rumored that on some people's laptops, it doesn't even open. So, okay, we went through it. Registration seemed okay, session control, but then there is this part with the AKA authorization. And also some mentions of IPSec tunnels, which are not optional. If you don't have support for that, the user equipment, right, the devices simply won't connect to the IMS network. So this was the bigger part, the bigger problem we had to solve. So I will zoom in a bit, and it hopefully doesn't get too technical. I'll try to keep it high level as we go through a full call flow of a registration, right, to establish the IPSec tunnel and see what problems we had to solve here. So we have the user equipment coming into the network via radio, and we have our three CSCFs, the proxy, the interrogation, and the server serving. HSS is pretty much your user location database, where the registrations and user profiles and all that. We get the SIP register, and of course it reaches on its way to the serving CSCF. We need to establish which SCSCF to use. There may be multiple of those. And you might notice a different color, right? We arrived via SIP, but now we are doing diameter queries. This is how the 3GPP recommends, or this is all standardized. So we send an UAR diameter request, which, going briefly through it, is just a way to learn the SCSCF, right? Learn which server to route it to, which SIP server. Okay, we got that. The UAA is the answer, right? The diameter is pretty simple, actually. It's just transactional, simple transactions. You can think of it as HTTP, why not? Well, instead of headers and values, you get AVPs, which are also like a key value way to put data in those messages. So now our register has reached the SCSCF, And the next step is to do the multimedia authorization, which is the MAR request. Here, we finally get the credentials, right? We get what we need to authenticate the user. The HSS also gives us at this step the authentication vectors, which are not going down too deep, but they are a way to ultimately ensure two-way authentication. So we are not just authenticating the user, but also the user is authenticating the IMS network. If it doesn't recognize the network, it won't connect to it. So that's where the shared secret comes into play. About the AVs, they are made up of 3 parts. First, the auth challenge and response is what we are already familiar with in SIP digest authentication. But there is also this third part with the CK and IK, which are the ciphering and integrity key, which are ways of establishing the IPSec tunnel. We can think of it that way, the IPSec. So we, in OpenSIPS 3.5, we abstracted all of this into 2 modules. First, actually 3. So first, there is this auth aka module that, if you look at the function call towards the bottom, it resembles, and you're familiar with OpenSIPS, it resembles the www authorize. Now we call it aka www authorize. And it will prepare the headers and challenges and responses and whatnot. Still, it will not fetch the AVs for you, because we didn't want to hard code this into the module, right? We wanted to keep things flexible. So we made an interface on top of that and wrote another module. So for starters, there is just one. There is just this AKA authentication vector diameter module, which obviously, right, fetches them via diameter. So it is the one who is, if you go back a couple slides, it is the one doing this MAR request. It is the AV diameter. But you could do it in the future, depending on how this thing takes off. You could be doing it in script. Maybe you could be fetching it from the database or through HTTP or a plethora of methods. So there is support for flexibility here. And the nice thing about it is that it's also async. So while that doesn't necessarily impact the latency of the call flow, at least it will do good things for your throughput, right? By freeing up the SIP workers. Right, so we've got the AVs now. We are heading the 401 response back to the PCCF. And here is where the magic happens. First of all, we need to, this is how the information looks, right? The nonce and the CK and the integrity key. And these things need to be stripped right now, and we need to create the IPSec tunnels. The whole mechanism is described in the technical specification written there, 133203. And here is how, let's say, how the IPSec tunnel parameters look like. So this is the register sent by the device, by the phone. You can see, I can zoom in a bit here. You can see there are some security parameter indexes in there, some ports, right? You get port C, which stands for client, and port server, what encryption algorithm to use, so on and so forth. Part of the 3GPP specification. But now also the OpenSIPS PCSF gives its own ports in response so that we can establish 4 IPSec tunnels. Why are 4 needed? Because it's like a full mesh here between UC is user client port and user server port. So each side has 2 ports, right? So 2 by 2, that's 4 tunnels. And also the protocols behave slightly different here in that if the phone is coming in over UDP, the response comes back over the same pipe. But if it's over TCP, you kind of need to make use of all the 4 tunnels. So UDP is only using 2 of them. TCP is making use of the whole tunnel across the whole exchange, right? The request and the routing of the response. Here is how the IPSec, so this is the third module that we abstracted into a proto IPSec module. We hope we did a good job on the interfacing. We try to keep it as simple as possible, made it like a new socket, right? If you're familiar with OpenSIPS script, it's a socket. You almost give it a protocol, despite its IPSec is not necessarily a protocol, and a couple ports, right, for the client side and server side. And then it will handle all for you. It will, that trickiness with the which ports to use, which direction to use, which all of that, it is abstracted away into the module, and the SIP messages will flow correctly. And this is how the route looks like when you route the 401. The on-reply route, you just do the IPSec create function, and it's actually parameterized, and you can choose, you can be a bit more flexible with it in choosing the ports and the algorithms, but let's leave it like that for now. And finally, the response arrives at the phone, and the IPSec tunnels are created. So now when it re-registers with the authentication header, the communication is done via the tunnel. It is encrypted. We go to the serving CSCF, and now we finally assign, this is another diameter request, SAR. We assign the user to the serving CSCF. That is it. We respond, it's a success. Let's say they had the correct password, and we are registered. Okay, so this was a big checkpoint. Only one last step before establishing the call. There was one little trick before we could get things working, because we had the problem now, okay, we are still unable to call each other. What is going on? So it turns out there was one more thing to be taken care of. That is the bandwidth reservation. You actually, for media to work, to flow properly in IMS, you also need to create a bearer, which is, you can think of it as a media pipe. And there are several layers of levels of guaranteed bit rates. Not going to go too deep into those, but yeah, depending on the scenario, on the purpose of your usage, right? If it's a VoIP call, if it's just a stream, you can use a lower bit rate for that. But in any case, we needed to create this bearer. So once the invite hits, we get the ringing, and now we have this interaction of the PCSCF with the PCRF component of the Open5GS. So here, like I said, it is the policy and charging rules function, acts as a firewall, and it allows us to create that media bearer. By the way, this is over the RX interface, and this is done using the AAR. So this is the fourth diameter request we are calling as part of the call flow, with the AAR opening up the media bearer, and finally we have the call established, and it was working. So that was a big milestone for us, getting the call working in a VoLTE network. Maybe what's to add here for the future, as we think about the next release, we could add in support for AKA version 2. Apparently, we can skip all of this IPSec complication altogether. So in 5G, they actually deprecated AKA version 1. And what do you know? You can do it just with TLS. So yeah, that was a fun one. All right, so what was the second problem we had to solve here was with the diameter support. Thanks to the people from the mailing list and the working group. Also, we were pointed out that in the same specification, there is also some references to deregistrations or profile updates which could take place on the IMS platform. as part of this CX interface I highlighted over there. For example, this RTR message, which actually makes sense. Imagine if you lose signal or you switch from from 4G to Wi-Fi, that connection is dead. So now you need to signal the server that the connection has ended. So that's an RTR. But what's special about it is that it's backwards, right? It's from server to client. So OpenSIPS actually needs to act as a diameter server now, and we didn't have support for this, right? We were just, up until now in 3.4, we were just able to push out that diameter requests, not receive them. So there we go. We made that happen as well. Actually, it was quite readily available. It didn't took too much, let's say, refactoring or changing that much. We were able to add this quite smoothly and get it to listen as well, and so on and so forth. So that was VoLTE and how we added support for that. With 5G, of course, you know, so VoLTE, which was back in 2010, 5G is 10 years down the road with better codec support, lower latency, faster call setups, and maybe download speeds of 20 times the speed of 4G. But also it comes with its drawbacks, right? You have to keep your 4G network as well when you implement it because of how easy it is to lose signal. And in offering support for 5G, apparently all we need to do, as far as we know, up until now, we haven't tested if it's fully functional yet. We just need to add support for HTTP 2. That the requirements are more centered around the 5G core rather than them changing too many things about the IMS core. So fortunately enough, that one seems to say the same. So on here you can see on the bottom is 4G, the evolved packet core, and on top is the reinvented core that is in 5G. But as far as we care, we only need to change our interaction towards that PCRF I was telling you. Now it's called PCF. They changed that one too, the name as well. Yeah, so it's more around functions, and it's using a lot of HTTP 2 in 5G. Yeah, NRF, NSSF, user data management, and all these buzzwords and acronyms that we need to acquaint ourselves with. But yeah, apparently, as I was saying, we can flip-flop between talking from diameter to PCRF. Now we talk HTTP2 to the PCF and manage the media sessions that way. We'll see if any other requirements pop up as we go along with the testing for 5G. Right, so now there is this new HTTP2 module in OpenSIPS, and it works both ways. Actually, this one works only as a server, and for client, you can just use REST client. I mean, libcurl is powerful enough to also act as a HTTP2 client, no problems. As far as presence goes, we also got some nice additions from NG Voice with this new reg event handling. It is a way to subscribe to changes in registration state, which apparently is useful in IMS. Yeah, so that's the new PUA reg info module. And there are some other goodies in there. For example, the AVP ops, if you're familiar with it, that's gone and refactored into SQL ops with a couple new goodies, like the ability to access the query API directly from script. For example, you could use that to write to DB text, something you could not do before, right? Because that doesn't have a query language necessarily. So now you can do that from OpenSIPS script if you like. The launch darkly integration, yeah, you can use it to host your feature flags in cloud and access them, of course. Check, for example, if some users have certain properties, usage rights, whatnot. Several extensions to SIPREC, from high availability and geo-distribution to some enhanced support in some SIP scenarios with reinvites, and the possibility to better edit the XML data. And on the steer shaken forefront as well, some some small tweaks. Now it supports multiple identity headers as well, with the advent of the RCD identity headers. That would not work with OpenSIPS too well, because it was complaining that you have two of them, and that works right now as well. Again, with some French stir-shaken things that aren't interesting. That was it with a summary. So a lot of work, as I was saying, went into the IMS part, from authentication, diameter server, and HTTP2 server support, making it quite a bit IMS focused this year. Specifically, as I was saying, on the CCSEF, we don't see much use for OpenSIPS on the other roles, but we'll see how things shape out. A lot of the suggestions and advice have come from the working group, and we are really thankful for everyone who helped. And of course, the 4G part is fully tested and functional. So you can go check out, put a link there about other features on it. About the working groups, I kept mentioning them. They are, we thought about it as a new way of gathering people interested on a specific subject and complex subject in telephony, such as IMS, and getting feedback and ideas on what to implement, what to prioritize, and what to do, what we are doing good and what we are not. So there's that. And finally, I'm happy to announce that we are planning on putting out even some community editions of this whole IMS support. There, we are thinking of making it like a Dockerized flavor, where you get all the containers spun up, and you can go test it out yourself. And similar with other products we have at SIP-Hub. So you can get like a basic version or idea on how they work and how you can integrate OpenSIPs in bigger services. So that was it. Let me know if you have any questions, and thank you for your attention.
Perfectly timed there, Liviu. Let's give you a round of applause. We're going into a break, but we do have time for a question or two. And I don't know whether you picked up, but Liviu said he's got some laptop stickers available, so you might be able to get one from.
So it's a very interesting presentation. So what was the driver for you to implement the IMS variation of SIP? Are you trying to put OpenSIP into the private 5G market? Are you just trying to sell to NG Voice? Do you have a particular customer that drove you to your prioritization?
That's an excellent question. We don't necessarily have a sponsor on this area, but of course NG Voice indirectly sponsors by giving this ideas and code and kind of ideas on how to make this happen. As far as the bigger picture, why not, right? Why not fulfill this role of making it work in an IMS network as well, right? It is SIP. And the specs are open. At the end of the day, why not have some open source implementation to go with it, right? And yeah.
Thank you. Jack's nodding. We can consider his question answered. Thank you. And yeah, Kevin's got a question for. I'm running up the back. Well, I'm not running, Kevin. I'm kind of walking up the back. But let's hand the mic to you.
My question is related towards the end of your examples with the RCD. Have you developed a perfect way to deliver the RCD without interfering with what the carriers will allow to be delivered?
As far as the stir-shaken payloads and the passport payloads go, I have to say we are pretty much agnostic, right? We just relay them. You get full control, what to put in there, what to remove, what to, so it's up to the user.
We're still all stuck with that third party that has the overall, like the DNS of the world of what goes into RCD still needs to be approved by somebody.
Yes, OpenSIPS isn't doing anything special on this front.
Thank you.
Also not on the signing part either, right? Because there you get the attestation and how to tell if something is trustworthy or we don't do anything there. So you would have to outsource it to some service.
Thank you.
maybe AI.
Thank you for your question, Conan. I think actually it's worth pointing out that OpenSIPS, along with a number of other open source projects, participate in OpenSIPit. And if Maxim was here, he'd be talking about OpenSIPit. It's an open gathering where compatibilities and interoperability are established. Okay, got time for one more question for Liviu, if there is one. Okay, if not, let me tell you what's coming up.